So for the initial parameter of our model was collected from base fish, and for the lengthening of the species that we have were mainly extracted from a reported catch, and we have the rate catch of the all species that we integrated in our model. The same thing for the food matrix that was estimated from the fish base. The same thing for the value of the biomass production and biomass and consumption on biomass, that their value exists already in the base fish. So let's discuss now the result of our model, and we have the first result of our model. It's the flow diagram, in which the diameter of the circles it's proportional to the biomass. Also the trophic level, it's divided here on 4 levels, in which the concentration of biomass it's dominated in the second and the third trophic level, which is the same thing that the statistical graph of the AMP report show. So the biomass it's dominated by the pelagic and the demersal fish. So we can validate the result of our model based on this statistical information that we have already. Also, we can deduce from this flow diagram that there is a balanced traffic between the traffic level, in which we can say that our ecosystem it's in phase of its instability. So the things that's confirmed by the statistical result. So we have the index of the primary production on respiration, which is superior than 1. That gives an idea about the photosynthetic activity in this zone. Also, the index of the primary production on biomass that showed that our ecosystem was an immature state, which means it's still in the development phase. Which is logic because of the geographic position of the Alboran Sea. So it's all time in exchange and in fresh water, which is the factor that makes him in the high biodiversity. And if we compare that with the statistical result of Lagoon of Nador, which is an ecosystem which is open to the Alboran Sea, so we can so it benefits from this biodiversity to be in the state of mature, and this is clearly with the index of the primary production on the biomass, which is inferior than 1. In the same logics, we have the mixed trophic impact that show that our ecosystem still in development stage. We haven't a high negative impacted group, but we have the positive impact, like the octopus, which is impacted positively by the epiphenalis. Also the sepia, which is impacted by the microphyte that able him in a high condition of the food resource. So the result, our result of model was really approximative to the real. So we need a sensitive study just to define the sensitive species, in which here we classify them in 3 groups. We have the first group in which we have the Decentractus labrux, also the Xavius, and the second group we have the Ingula and the Tractus mediterraneus, which are the priority species in this area. Also, in third group we have the sardine, the Melis barbatus, which we have the presence of those species with an important quantity in this area. So from all of that, we can really deduce that that state of Alboran Sea that's characterized by a high biodiversity. also a large catch volume because of the industrial fishes that we have here, without forgetting that we have the liquid pollution that can impact with time to have an extension of several species. And this liquid pollution is due to the maritime transport that we have here in this Alboran Sea. So from all of that, we can say that the result of our model was approximative to the real situation that we have in our ecosystem. And we can say that our study achieved the aims. We can say that we have really achieved the aims of this study that can be combined with other study like the hydrodynamic models that we really needed here because of the current that we have, the current waves that we have here in this area. So also to study more the interactions in this area, and this is the objective by the ecology in the end. And of course, with my all sincere thanks for your time and for your listening. Thank you.